Hi friends, welcome to our channel. Today let's discuss about the graphical representation of motion. That is, we are using graphs to describe a motion. What is the distance covered, how much time the object has taken to cover that particular distance, or what is the velocity of that object, or is there any acceleration, what type of motion the object was having. All those will be spoken by a graph. In this class, we will be discussing about two graphs, that is distance time graphs and velocity time graphs. So this is the first type of graph that we are going to discuss. In a distance time graph, we represent the change in position with respect to time. That is, we'll talk how the distance is varying or the position is varying with respect to time. In a distance time graph, distance or position of the object is represented in the y-axis and time is taken in the x-axis. So let the unit of time be seconds and unit of distance be in meters. Alright, so using this distance time graph, we can say whether the object is moving with a uniform motion or if the object is having a non-uniform motion, or we can even say whether the object is at rest, that is if the object is moving or not. Okay, so we'll discuss all these three cases and we'll see how the graph will look in these three cases. Alright, so first, in the uniform motion, we know that the object will cover equal distance in equal time, right? The object will cover equal distance in equal interval of time. That means in this case, distance and time are directly proportional, right? Since the distance and time is directly proportional, in the case of a uniform motion, the graph for a uniform motion will look like this. It will be a straight line since both these quantities are directly proportional. Now let's see what will be the shape of the graph in the case of a non-uniform motion. In the case of non-uniform motion, this proportionality does not exist. That means the object is not covering equal distance in equal interval of time. That means this proportionality does not exist. Distance is not directly proportional to time. So we can say that, or we can draw the graph. This is distance and it is time in the x-axis. In this case, the graph will be a curve for a non-uniform motion. It will be a curve because distance is not directly proportional to time or the object is not covering equal distance in equal interval of time, right? Now, what about the shape of the graph if the object is at rest? What is the meaning if the object is at rest? That means the object is not moving, right? The object is not covering any distance. So if we have distance here and time here, the graph will be a straight line or a horizontal line, right? Like this. The distance is not changing, but the time is passing. The time will change or the time will pass, but the distance will not change because the object is at the same position. It is not moving. Okay, now so far we have discussed how a distance time graph will look like for a uniform motion, a non-uniform motion, and if the object is at rest. We know for a uniform motion, the distance time graph will be a straight line like this because the distance and time, both the quantities are directly proportional. That is, the object is covering equal distance in equal interval of time. As you can see in this graph, here in the first 20 seconds, the object is covering 10 meters. How will you find that? Just draw perpendicular from time and then extend it to the y-axis, that is distance. So, if you extrapolate or if you extend like this, you can see in the first 20 seconds, the distance covered by the object is 10 meters. And now in the next 20 seconds, that is in the 40th second, the object has covered, if I draw perpendicular like this and then extend that perpendicular to the distance axis, you can see in the next 20 seconds, that is in the 40th second, the object has covered 20 meters. Similarly, in the next 20 seconds, that is in the 60th second, the object has covered 30 meters. So, here the object is covering equal distance, that is 10 meters in each 20 seconds. But in the case of a non-uniform motion, the graph is a curve because why? The distance and time proportionality is not existing here. So, the object is not covering equal distance in equal interval of time. It will be the distance covered in each time interval will be different. And if the object is at rest, the distance time graph will look like a horizontal line which is parallel to the x-axis. Now further, we shall study how to find speed or velocity using a distance time graph. The speed will be equal to velocity if the distance is equal to the magnitude of displacement, right? So, let us see how to find speed using a distance time graph. Before that, let me note down the formula for speed. Speed is equal to distance by time, right? So, here let us take the case of a uniform motion. Take any interval of time, and in that interval of time we shall see what is the distance covered and then calculate speed using this formula. So, we get the speed, right? Now, that speed will be equal or that speed will be same for any interval of time that you consider in the case of a uniform motion, because the speed is constant, the speed is same in the case of a uniform motion, right? So, let us begin. Here, let us take this interval, that is between 20 and 40. Let us name this as T1, this as T2. After drawing perpendiculars like this, distance corresponding to T1 will be S1, that is distance 1, and distance corresponding to T2 will be S2. I hope it is clear. This is T1, this is T2, and the distances corresponding to T1 and T2 will be S1 and S2. How will you get that? Just draw perpendicular like this to the graph and then extend that perpendicular towards the distance axis. So, now we are considering this interval, right? So, the formula for speed will be S2 minus S1 divided by T2 minus T1. That is we are calculating the distance covered in this interval of time. So this is the final formula for speed, or this is how you calculate speed from a uniform speed from a distance time graph. Speed from a distance time graph. Now similarly, in the case of a non-uniform motion, you can draw perpendiculars like this. Extend towards the distance axis and name this as T1, this as T2, corresponding distances as S1 and S2, and then here velocity will be S2 minus S1 by T2 minus T1. So this is how you calculate speed from a distance time graph. Now please note that in the case of a non-uniform motion, the speed or velocity that you calculated in one interval might not be same in the next interval. That is, here the speed or velocity is not constant, it is changing. So if you calculated the speed for this interval, this particular interval, then that speed might not be equal as this interval. It will change because the motion is non-uniform, that is, speed is changing. I hope the point is clear. In case of a uniform motion, the speed calculated or velocity calculated will be same for any interval you take. But in case of non-uniform, the speed will not be same for any interval of time that you consider, because the speed is changing with respect to time. Now let's discuss about velocity time graph. Similarly, like distance time graph, velocity time graph also talks about the nature of the motion of the object. That is, if the object is having a uniform motion, a non-uniform motion, if the object is accelerating, in case if the object is accelerating, what is the acceleration of the object, all those information is conveyed using a velocity time graph. Now let's study each cases in the case of a velocity time graph. Here, this graph, which is a horizontal line parallel to x-axis in a velocity time graph, represents a uniform motion. Why? This is representing a uniform motion. Why? Because in uniform motion, the speed or velocity is constant. It is not changing. The speed is same throughout. That is why the object is covering equal distance in equal interval of time, right? Since the speed is constant, we say that the motion is uniform. Alright, so in the case of a velocity time graph, the speed is constant for a uniform motion. That's what we said. So here, when I draw a straight line, that means a horizontal line parallel to x-axis, that means even if time is passing, my velocity is the same. It is not changing. In the first 2 seconds, it is 30 meters per second. In the next 4 seconds, it is again 30 meters per second. So in any time interval that you take, my velocity is constant. Thus, for a uniform motion, a velocity time graph will be a horizontal line like this, which is parallel to the x-axis. But in the case of a non-uniform motion, or I can say accelerated motion, right? Because the object is accelerating. That is why we say the motion is non-uniform. Here the speed is not constant, it will change. So here this graph is a uniformly accelerated motion. Uniformly accelerated motion, that is the value of acceleration, or the object is accelerating uniformly. It is changing its speed in a constant rate. The speed is increasing, but the increase is at a constant rate. Here you can see in the first 5 seconds the velocity was 10 meters per second. Then in the next 5 seconds the velocity has increased to 20 meters per second. In the next 5 seconds, so we are talking about each 5 seconds increment. So in each 5 seconds we can see that the velocity is increasing 10 meters per second. I am talking about in this example, in each 5 seconds the velocity is increasing 10 meters per second. So in this case this is a uniformly accelerated motion, that is speed is, or velocity is increasing uniformly, or it is, the object is uniformly accelerating. Now looking at velocity time graph, you can find two different quantities, that is distance covered by the object and acceleration. We shall discuss each one of this separately. First let's talk about the distance covered by the object during any interval of time. So if we need to find the distance from a velocity time graph, we will calculate the area under the graph. Area under the velocity time graph. So basically area under the velocity time graph will give the distance covered by the object during any interval of time. So let's take the same example and let's consider this interval between 2 and 6. So as we know, let's draw perpendiculars like this. We are considering this interval, right? The time is 4 seconds between 2 and 6. So let's write this as T1, T2. So we are considering this time interval between T1 and T2. Now this area, the shaded portion, that is the area under this curve, will give the distance covered. So here distance covered between time T1 and T2, it will be given, let's name this as rectangle ABCD. This will be given by area of ABCD. So this rectangle will give the distance covered by the object during time interval, this time interval, that is between T1 and T2. So here area of a rectangle is length into breadth. Here length is AB, right? AB into breadth, we can take it as AD. AD. So that is, this is 4 into AD is 30. 120 meters will be the answer. Now let's see how we can calculate acceleration from the same graph. Now acceleration is given by the slope of a velocity time graph. What is the meaning of slope? Slope means slope, I hope you guys have studied in maths, it is y by x. Okay, so here let me take this example to show how to calculate acceleration. Why not this example? Because in this case acceleration will be 0, because speed is constant, speed is not changing, or the object is not accelerating, thus the acceleration is 0. So let's take this example for calculating acceleration. Now in order to find acceleration, what you need to do? You need to find the slope. So let's take any time interval. I'm considering this time between 10 and 20. What will I do? I'll draw perpendiculars like this and find the corresponding velocities. Okay. Let me make a triangle like this. This is my T1, this is my T2, and then this is my corresponding velocities, right? So this is my V1, this is V2, right? Now acceleration is V2 minus V1 by T2 minus T1. That is velocities. We all know that acceleration is rate of change of velocity, right? So we'll find the velocity in the time interval that we have considered, and then divide that velocity with the time. So here velocity is V2 minus V1, and time we can consider it as T2 minus T1. Thus we find acceleration. Now in case if you want to find the distance covered in the case of non-uniform motion, how will you do that? That is, let's consider the same time interval T1 and T2. Okay, so we know previously we have discussed distance traveled or distance covered by the object from a velocity time graph will be given by the area under the velocity time graph, right? So here, since this is the time interval that we are considering, this is the graph that I am talking about. This is the curve. OB is the curve that I am talking about. So I'll have to find this area. This area will give the distance covered by the object during the time interval T1 and T2. And I have named this way. That is, this area is looking like a trapezium, right? So the distance is area of trapezium ADBO. This trapezium ADBO. So this shape you can split into two parts, a small rectangle here and a triangle here, right? Though this looks like a square, Let's consider this as a rectangle. So area of rectangle ADCO plus area of this triangle COB plus area of triangle CBO. Okay. Now, how to find area ADCO? It is nothing but breadth into length. Here breadth is AO into AD plus area of this triangle is half into base into height. I hope you guys remember the formula for area of a triangle. Area of a triangle is half into base into height. Here let's consider this as base and this as height. So it is half into OC into BC is the height. So by finding out those values and substituting them in this equation, we can find the distance covered. Here are some more velocity time graphs that you guys must know. In this first graph, you can see that the velocity is decreasing with time. That is, acceleration in this case is negative. In the next graph, the velocity is varying non-uniformly. In some portion, there is an increase in velocity, that is, it is a positive acceleration. In some portion, it is negative acceleration. So in this graph, or this graph represents a non-uniformly varying acceleration. Non-uniformly varying acceleration, or you can also say that this is non-uniformly varying velocity.